So, first things first, could you explain what you guys are demonstrating today?
So we're here today at Hardware Pioneers to talk through how we can help accelerate hardware companies to put AI onto their actual devices. And we provide an engineering tool and a platform that helps you take data from the real world, turn that into an edge machine learning model, and then deploy it to any device. We're talking anything from an MCU all the way up to GPUs and sort of embedded Linux devices. And this particular demo is looking at how we can use synthetic data to train models. So we've recently partnered with Nvidia and their Omniverse tool to help people create virtual environments. This is an example looking at a virtual factory, a factory floor where we have pallets on a pallet truck. And one of the problems that I see a lot when I talk to my customers in the industrial field is that they want to create machine learning models to do something. In this case, detect how many pallets are on a pallet truck. But actually installing a camera on the factory floor is really expensive. And if they had to disrupt production, it causes other costs. So if what they can do is create a virtual environment that mimics what the factory floor looks like, they can create huge synthetic data sets really easily that then allows them to train a model that works just as well in the real world. So you can see here we have a bunch of images that are from this virtual environment. But then when we run that model in the real world, up in the top right, it's able to look at a real pallet truck on a real factory floor and detect those pallets just as well. The other thing that we're showing here today is the power of edge impulse to shrink down your models. So traditionally machine learning has been something that has had to run on cloud hardware or on really big edge gateways with big Nvidia GPUs. Nvidia has allowed us to take their Tau model library, which is their industry-specific model architecture library with a bunch of different models tuned for a bunch of really cool different applications. And we're able to compile those down to run not only on Nvidia devices, but on any piece of edge hardware. So we can take you from an Nvidia Jetson Orin with a BOM cost of maybe $1,000 and put that onto something like a Renesas MCU, which maybe has a BOM cost in the region of tens of dollars. So when you're trying to scale production from something like 1 or 2 cameras in the factory floor in one factory to 1,000 across your entire production system, or even if you're trying to scale production from a prototype to a consumer product that has millions of devices out in the field, the really important thing is your BOM cost. And actually AI has a real impact on that BOM cost because it's resource intensive. So if we can compress those models down for you and make them run on cheaper hardware, then it saves your customers money.
So 2 things that stand out to me. The first one is the use of synthetic data. So in order for that to work, I take it you have to have almost hyper-realistic simulations where you can extract the camera virtualized image, if that makes sense.
Yeah, so that's where Nvidia comes in. They have a huge amount of expertise in creating. You think their kind of bread and butter has been video games for the last 20 years?
Of course, yeah.
So they've created a really great set of engineering tools in Omniverse that help you create photorealistic scenarios really accurately, but also programmatically add in noise, cracks, things like that make it a much more realistic environment. They have a huge library of assets as well, which make it easy for industrial applications to spin something up quickly.
Because that's been one of my major concerns when it comes to AI training is the use of synthetic data. Because I think a lot of self-driving companies are trying to use that same kind of data, and while it can accelerate the ability for an AI to do well in that task, my concern, like you say, is that if you haven't got enough noise or enough variation that properly reflects real life, it might make decisions in a slightly different way. So I'm kind of curious how you address that issue.
So I don't think synthetic data is ever a silver bullet, but it's always a really good starting point. So what we always recommend, and it's part of the ethos of Edge Impulse, is creating an active training loop. So you maybe would deploy this initial model back into the factory, but then we can help you bring data back from that model for like a user trial to help you retrain a model with real data, but that's informed by the synthetic data that it's been trained on. So the idea is that you use it as a baseline, and then you always supplement with real data. It's the same reason why we don't provide off-the-shelf pre-trained models, because you can never be certain that they'll work in every environment. And actually, for companies generating their own IP, if you want to generate really good IP, use your own data, you've got something that you can really defend there.
That does kind of make sense, because even with language models, you can get a base trained model, but you need to still add your own data to make it do something you want specifically, whether it's prompt engineering or like a writing style. My second question is about the shrinking of the model. I take it you have to quantize that data lower and lower so that it can fit on a microcontroller compared to a large GPU. So does that come with the issues of like loss in precision and stuff?
So there's a few approaches that we take for making models fit onto tiny devices. One of them is shrinking the model itself once it's trained. So that's through things like quantization and pruning. And that does have sometimes an impact on the accuracy of your model. But we provide you with tools that help you quantify that and then decide. Then the other side is actually just being more aware throughout the entire model development journey of the hardware that you're targeting. So we have tools to help you simulate how these models will run on lots of different types of hardware. So you can get an idea for which model architecture is going to be best. So I'll show you a tool that we have called the Eon Tuner. And this is a really cool, powerful tool for running tens of experiments all at once.
Oh, that's brilliant.
And what this does is it runs experiments over different types of model, different types of input resolution, different types of backbone, RGB versus grayscale, and then we see them all in this lovely grid which shows you the model accuracy but also the performance on device. So this is targeting a Renesas MCU.
But that means you can find out if you've got enough resources in the first place.
And because actually a lot of the model performance comes from the model architecture you choose, maybe you'll find that actually, okay, this MobileNet version isn't going to fit on my Renesas MCU, so maybe I would go for a different architecture. We, for example, have the FOMO architecture, which is an in-house model architecture we've developed, which can fit an object detection model in sub 100K of flash. So that's a really interesting option for companies who are really resource constrained. But these are the tools that we developed with hardware in mind for helping you evaluate and identify all the way from the beginning, from data all the way to deployment, how you create a successful product with edge machine learning in it.
For people out there watching this video, if you look closely right here, they're using the You Only Look Once model, which is a very famous model for image processing. And another question I have as well is, do these kind of target platforms, do they have AI accelerators built into them in order to be able to run these models?
So there are really two types of hardware that we find. One is we can run on anything that has a C++ compiler and 32-bit floating point math. So that's anything from any of the ARM Cortex-M range upwards on the MCU itself or the CPU. But then a lot of companies now are bringing out hardware acceleration into their chips. So we support Nvidia, we support a bunch of other ones from our other hardware partners. But then what we're also seeing now is ARM themselves have recently announced the U55 architecture, and that's very popular. Something like an M33 plus U55 can give you really good performance with something like a YOLO model or a MobileNet model, up to 60 FPS, which traditionally you would need a really high-powered GPU to do. So our platform is there to support you not only if you're running core MCU or CPU, but also to take advantage of hardware acceleration where we partnered with those different hardware companies.
Fantastic. And honestly, I'm just quite amazed that you can shrink down a model which would typically be trained on a very large GPU or a network of GPUs, and then shrink it down to a microcontroller which hasn't even got an AI accelerator, as long as it's got a 32-bit floating point. It's absolutely astonishing. Like, honestly, I've got no words. It's actually truly amazing. So,
I think one of the things that is important to remember is that when you look at a big model like a YOLO model or a MobileNet model, it's such a large model, but actually if all you want to do is detect pallets, we're restricting down that use case. Right. You can take some of the knowledge distilled in that model architecture and use transfer learning to create a much, much smaller one that's really fine-tuned for a particular use case. And that's where a lot of the saving comes from.
Absolutely fantastic. So, just before we wrap up this video, I've got one more question for you. For the engineers who are watching this video, if they want to get involved with Edge Impulse Solutions, what would you recommend that they do?
So we have a community platform for education and exploration, which you can sign up for free, and you get a little bit of compute to play around with. We have a huge library of different example use cases you can explore. But then if you have a production use case that you're looking to accelerate, then get in touch with us and we can talk about how our team can bring their expertise to you and how you can use our platform to really accelerate your journey from prototype all the way through to production.
Fantastic. Well, you heard it here first. Thank you very much. It was a pleasure to meet you.
Nice to meet you. Thank you very much.